So that's all nahi hai, sir. Means to say our course is everybody, everything understands.
So this we got from the Google Forms.
So we'll take it up.
Yes,
First read it.
Yeah.
Kindly post. This is what it is.
Yes. Yeah.
Sorry. Shubham Avasthi is once again here.
Yeah. He joined the session, sir.
Huh?
Yeah, we are live, sir. Yes.
Okay, so welcome back. So I see Shubham Avasthi already shooting questions. So Shubham is a customer for our second course also. Okay, those of who are for this hangout for rapid manufacturing, welcome to this course. I and Dr. Amandeep Singh, both of us are here. So we would like to answer to your queries. And if we are stuck without explanation, so we will get back, we'll put it on the forum. And to a large extent, we will try to help you in understanding this course more. Okay, so let me start with the live question. Shubham Avasthi, I did Masters in Product Design and Development from NIT Warangal and presently working with additive manufacturing and green manufacturing at our college in GEC Banswara. This is in Rajasthan. I joined in CEG Banswara as an assistant professor in mechanical under the TechCube scheme. Fine. I wish to apply for a PhD under QIP program at IIT Kanpur. Is there any chance for me? Yes, sir. So if you are a QIP candidate, you should apply. There is you don't have to apply only through QIP. You can also apply through regular. So please apply. There is a procedure there, and IIT Kanpur website has all the procedure. And all the best to you. Okay, and good luck. So we will go ahead with some of the questions from the forum. The first question is Akshay Kumar, a faculty, sir. If we get good marks in rapid manufacturing course, does there will be any summer internship under your guidance? Ajay, as I told you for the previous course also, that TechCube, if you are part of TechCube college, then you can apply through TechCube. And if you are a faculty, if you want to come and spend a week or 2 weeks, we encourage. But we would always expect you to come with a problem statement wherein which we can also jointly work with you and both of us get benefit. Akshay, sir, can you please suggest topics related to rapid manufacturing for MTech thesis? Akshay, yes, today there is, if you are interested in metal forming, there is a topic called incremental forming which is coming up. If you are looking for anything in additive manufacturing, yes, there are coming up, and rapid tooling, which is more talked about today, and directly using parts for real-time application in rapid manufacturing through SLS route or SLM route, that is also coming up. Lens machines, layered engineered net shaping, these machines are also talked about today. So there are a lot of topics which is coming up, and when you talk about all this polymer, if you want to develop a model for it, that's also currently we are having a lot of assumptions. We are no way predicting the correct results. So if it is a 2D, yes, it is easy. If it is 3D, it is going to be very tough. So a lot of analysis, thermal analysis for polymer products also can be done as part of your MTech thesis. Shubham Avasthi, once again, as we are, as my research is in the area of rapid prototyping, so is there a chance for us? Yes, I have already told you, please do visit us. Next is Ramkumar Mehta. Will how much negative marking in this external exam? I think it is no negative score. Okay, until and unless there is a big change at the last minute, which then we'll keep you posted. As such, as of today, there is no negative score. Lecture is too long and hard. How to prepare for external exam? Give me any suggestions. We will be sharing the transcripts maybe within a week's time. So I think once the transcripts are there, your preparation should be much faster. Pragat, yes, I don't have any question in it. Fine. Prathmesh N. Patil, a student. What is the actual laser beam machining? We are in the 5th week. I suppose you will have slides which are coming up on laser beam machining. And in laser beam machining, what you have to understand is I am using a heat flux, and this heat flux is focused, so I can change the energy make the material melt, make the material to join, and just do a surface heat treatment. So whatever I want, I can do. And laser is one material where photon is used as the energy source, and this energy source does not require any vacuum. It travel anywhere, and it can be very easily moved from one source to the other source. So that's why laser is very much talked about in rapid manufacturing processes or in additive manufacturing processes. Regarding laser and its software working, Abhay Kumar. Um, the question is little vague, so I'm not able to understand, Abhay, what you want to convey. So if you can give us more clarity, then I can help you. Surya, student, like, the question is incomplete, so we'll go to the next question. Shreyas, can you explain the present research and the industry status of fused metal jet 3D printing and other related liquid metal additive manufacturing process? This is also lined up in the 7th and 8th week. So you can post this question after listening to those lectures in the forum, and still stuck, we will be there to help you. And G. Mahesh, a student, opportunity based on rapid manufacturing. This is more talked about, and industries have now started looking into biomedical field. There is a lot of need and appreciation for this concept of biomanufacturing or rapid manufacturing. So there is a huge scope. Try to understand who is your customer, what are you trying to make, and what is the sustainability from both from finance as well as from energy model for the rapid manufacturing process. Then Manish Nair, professional, sir, could you please explain the additive manufacturing concept in case of metals and composites? Sir, till now we were talking about polymers and ceramics, and we were happily using lasers. Now metals are have been started discussing more and more and more, because the metal powders are coming up in a big way. So joining these metal powders are becoming easier by using laser. So there is a huge future for it. And as far as composites are concerned, today there are materials which are getting built, wherein which metal which is getting integrated with ceramic material, or a polymer with a ceramic material, they are getting integrated. So during the process, they get melt and they get joined. So composites is also talked about more today. And apart from that, people have also come up with filament winding, filament process, which is used in FDM. So wherein which along with the polymer, they have integrated also glass fibers for developing material. So this field is growing now, and a lot of research work is going on. Next is Dinesh Babu. How to fabricate customized 3D printing filament. See, 3D printing filament, people have started working on it. So people have started customizing. In fact, for biomedical applications, people have started making their own gels. And so when you talk about filament, the process sequence is going to be polymer pellets getting extruded into a wire. So that's the process. And today what has happened is, depending upon the strength requirement, varying compositions of pellets are added together and the wires are made. In fact,
green materials are coming.
Green materials are coming, correct. And yeah, when we talk about medical applications, biodegradable polymers are also there. So a lot of things are coming up. How to fabricate customized 3D printing? You make a choice, and then you have to mix it to the ratio. And when you talk about polymer materials, it's very clear you have to work with only viscoelastic temperature or glass transition temperature. So at that temperature, you have to extrude it and then get a wire. So there is research going on. People have started working on integrating nanospheres in it. People have started mixing fly ash to it. So a lot of work is going on in laboratory scale. Prajina, NV, faculty. Can you explain the CCD scanner used in non-contact sensing? See, basically, CCD is a normal camera. Don't get into deeper. So it's a camera wherein which you can record information what is there. So basically, you will follow the principle of triangulation. Use a light source. When it hits a surface, it reflects. Now capture the reflecting surface data, light, whatever it is, through a camera. So that camera is charged coupled device, CCD camera. That's all. So through this, what we do is we try to record the surface information, and when we start stitching this dot into line, line into surface, we try to reconstruct the surface. So it is exhaustively used in reverse engineering. Okay, now new questions added. Akhil Prasad, explain 3D printing in food industry. See, in food industry, basically,
3D pizza.
yeah, Amandeep makes a comment, and he says that we can think of making 3D pizzas. So you can do all the topping using 3D printing technology. So if I can write happy birthday on a cake, then I can also do anything on top of a pizza. Okay, this is on the lighter sense, but now a lot of gears, nylon gears and Teflon gears are made out of 3D printing for the application. And sky is the limit for your creativity. Moment you have understood the process, moment there is a customer there, now you start blending your creativity into it. Process known, customer known, and how do you develop it? Okay, Ayush Gupta, hello sir, can you please show us some practical demonstrations for better understanding the process? Yes, in this course, that's the USP of the course. So we will show you 3 or 4 processes. We are also trying to show reverse engineering techniques. So please do stay with us, don't leave the course. And all our courses, we have been practical all the time. And Amandeep has taken a lot of pains in doing the practical and also giving explanation simultaneously so that you can enjoy and understand. And more than that, if you have questions, forum is there, so you are most welcome. We will try to help you out. So any more questions? Hmm. Okay, so there are some more questions which are added. Please suggest some topics for MTech production dissertation in rapid manufacturing. That's what I said, sir. It is left to your capability. If you are good in process development, you can always develop new process for new materials for new customers. If you are very good in modeling, so there is when you start working with metals or with polymers, there is always a shrinkage component. So how much does it shrinkage in all the 3 directions? If you can start modeling, that will also be great. Okay, and sky is the limit when you start working on your dissertation problem for in the area of rapid manufacturing. Up to what limit can we reduce the staircase effect? That depends upon the raw material used. That depends upon the process. For example, if you use a filament winding process, it is very difficult. If you start using powder as a starting material, it can be reduced to a large extent.
Post processing.
And it also, so if you want to completely avoid, you do a post processor, get it done. I am Vijay. As a bachelor student, like to know more about multi-nozzle spraying and producing product consisting of composite material, for instance, mixture of metal, polymer, and so on. So the question is not very clear. What would you like to know more? So please, I would request you to be a little more clear in your question. Motivation guide. Does this topic cover in the course? Can you show a glimpse of it? Multiple nozzle in 3D printing, yes, we teach. But composite material, we don't cover that. So basically, the topic what you are discussing, we will not cover in our course. It is beyond the scope of this particular syllabus, whatever we have given. Okay, any more questions, please? So, sir, do you see 3D printing will replace conventional machining process? Yes, of course. Of course. See, whenever you have a large structural applications, conventional will not go. But whatever are now, when we talk about the concept of miniaturization and the complex parts, 3D printing will take over because this process is more energy efficient, 3D printing. Please don't go by 3D printing alone. If you make it as additive manufacturing, yes, that is going to take over. 3D printing is one process. I am generalizing your 3D printing into additive manufacturing. Since you have a building block as a starting material and you start adding it as and when it is required, it is going to be more energy efficient, especially in metals. Yes, that's what is leading to rapid manufacturing today. Today, a lot of gears are made using that. Lot of dental applications are made through that. Lot of biomedical applications are made through it. Lot of nozzles for aerospace applications, for auto applications. We are looking forward for it. When you talk about inclusive society, people who have peculiar requirements. So all those requirements, custom, we do and then identify what they need and then we start doing it. Sir, Ajay Venkat, sir, is there any kind of summer faculty internship program? See, sir, as I told you, if you are a faculty and if your institute is under TechCube, you are most welcome to it. If it is not so, if you can come with some problem statement, we can try to help you. We'll be happy. Dinesh Babu, how to fabricate customized filament for 3D printing? Sir, you take whatever you want. Varying compositions you can take. Now, after you take, if you can push it through a injection molding machine, okay, where there is a barrel, inside a barrel there is a screw, and what exit from this injection molding machine nozzle will be a continuous wire. So if there is a continuous wire which is coming up, so then that wire becomes a filament. Okay, moment there is a filament, now you can start using it for requirement. Is there any research center available in India? You should try to contact SIPET, because the government of India established SIPETs, and of course some of the academic institutes also work in it. Well, Murugan, sir, what are the materials used for rapid manufacturing? Choose polymer, ceramic, metal, whatever you want. So basically, if you want to understand clearly, there are three types of materials: polymer, ceramic, and then there are three forms: solid, liquid, gas. Then it can be a powder, it can be a filament, or it can be a layer. So you can have this.
Regarding internship, new information is coming. We'll post this link. So where faculty can decide about the toppers who can take them. So this is a new information that is coming.
Okay. So just now we got an information through our NPTEL cell. So Mr. Murali has helped me in giving it, and Murali has been helping us all the time during the course and while preparing Hangouts. So he just shared an information that there will be a website which is posted shortly, and this will be for summer internship alone, summer and winter internship alone, and for toppers in the course. Okay, those people who excel out, they stand a chance for getting internship from any of the institutes where the instructor is. Okay, so good luck for it, and thanks to Murali for sharing this information. I'm sure this will be posted in the website of NPTEL shortly, or it is already there. Please check it.
We'll post it in the forum.
We will also post it in our forum. Okay. We will. Yeah. So after this itself, I would request Murali to post it, so you will all see and apply for whatever is the requirement. Can we achieve the same strength as that of metal with products manufactured from additive manufacturing? Yes, there is a small difference. Yeah, if you try to make a conventional product and then machine it, get the output, the strengths will be different as compared to that of additive, because additive is a layered manufacturing and it is anisotropic in nature. So there will be a strength compromise. But if you play properly in developing it, the orientation of the build, so to some extent you can get out of this strength issue. Prajina NV, sir, the scanner explained in 3D scanner are CCD scanners. What is CCD? What is the CCD? Can you explain? CCD is like a camera, sir. It works on the concept of charged coupled device. You can do Google and get more information about what is CCD. But here, since it's a technology-based course, we are using the technology for doing reverse engineering. So from this course, what are you supposed to know more is what is the technique which is used in CCD such that I can do reverse engineering. So what is the technique? It is nothing but triangulation technique. CCD is a normal camera, sir. That's all. If you can have a, see, when we study light, what do we say? We say that incident angle and reflecting and the reflection angle will be the same. So the incident, the reflection and the normal should be in the same plane, something like that. So the CCD is the reflecting light which comes out from the surface. You capture and you try to get data. My working institute is okay. Ajay Venkat, your working institute is not a TechUp institute. Now you will get the website. You can apply, and good luck for you. Dinesh Babu, sir, how you see the impact of 3D printing in medical field? Huge, huge. Because no two people will have the same type of requirements. Though it is still not practiced. You just see, if your son falls sick, or 5-year-old, if you fall sick, your wife falls sick, your mother falls sick, we all take only the same tablet called paracetamol. Which we all see. When I said son, his body to mass index is different, his age is different, your age, your wife's sex, and you see your mother sex, mother age, body to mass index, everything is different. Currently, what is the practice we do is we just normalize and we try to have a tablet. But in future, this will not carry on. There will be very, very huge requirement for mass customization of medical devices and medicines. So there is a huge scope for it. Why the products made by reverse engineering are not homogeneous? See, when you do a reverse engineering product, you will always get a point cloud data. And when you have a point cloud data, you have to work on the data for a long time so that you try to do all the patches and try to get a proper 3D form. And when you get a 3D, you just put it back into the machine and start printing it out. So when you print it, it is not a homogeneous process. So that is why you have a non-homogeneous nature. Ajay Venkat, thank you, sir. Okay, Chandramohan Velayyan. Sir, is it able to produce in mass quantities in additive manufacturing with low cost? People are looking for these alternatives, sir. People are looking forward for these alternatives. So earlier, the companies which used to sell 3D prototyping machines, they used to have proprietary item as their raw material. Today, they have opened it out. So now once there is a third-party raw material, the cost for the raw material has slashed down drastically. So yes, there is a move, or the research is moving, or the technology is moving towards mass customization using 3D printing. So Shubham, thank you. Okay, sir, I will plan coming sometime. Okay, good. All the best. Prajina, thank you, sir. Fine, thank you. It's a pleasure. Any more? So along with me, we have Dr. Amandeep also. So I would request Amandeep to share his thoughts, his guidance as far as this course, how did we plan, and what is expected out of this course. So I would request Amandeep to join us. And I am also there. So we both are here. So questions posted to him or posted to me, we both can address. So I'm handing over the mic to Dr. Amandeep.
Thank you, sir. So you are welcome to ask any other questions if you like to. So next question is by Dinesh Babu. Could you brief about fabricating a filament extruder? Sir, just explain that filament extruder is something we have pellets, and that is just a general extrusion machine. We have to develop a filament. We have to develop a continuous wire out of that. So that is not mentioned or not explained in the course, because we are more talking about the rapid manufacturing processes, not the raw material manufacturing, raw material for rapid manufacturing. But yes, we'll discuss the raw materials for rapid manufacturing, or raw materials in rapid manufacturing. They will take that as one of the lectures for different processes. What are the materials, the forms of materials, which are sheets, powders, wires, then kinds of materials for different processes and different resolutions or different accuracy we require. So next is Prajina. Can we produce all kinds of materials in reverse engineering? Prajina, if you say all, I can say almost all, because reverse engineering is, we are not producing anything in reverse engineering. Reverse engineering is, we are just scanning and producing the design again. Now manufacturing is a separate tangent to it. So reverse engineering is just making the making some changes in the present product, or just copying the product to make it in a different way, to manufacture in a different way. So there's certain questions coming. Okay, one question I'd like to talk about the cost. One person asked. We'll definitely have a lecture on cost, that how economies of scale helps to reduce the cost of the product, and how additive manufacturing or rapid manufacturing is changing the present manufacturing scenario. So we'll discuss that when we'll talk about the costing in rapid manufacturing. So can we use RPT in biomems or in microsystems? Yes, we have already said that there's a huge scope of rapid manufacturing in these materials. And whenever there is a miniaturization, small systems are to be manufactured. So the small tablets and small medicines, those all can be manufactured using the rapid manufacturing processes. Akshay, sir, please suggest books on rapid manufacturing for self-study. Akshay, in the course information phase, we already have 3 or 4 books as references, and also we keep posting the references in the end of lectures, so you can follow them. And if you like, you can ask this question in the forum, and I'll ask my TA to reply with the link to the course information forum, the homepage for the course. There we have the books. Rachina, okay, only the 3D design manufacturing by RM. Prajina, I believe question is not very clear to me. Only the 3D design manufacturing by rapid manufacturing, question mark. Yes, reverse engineering, we do 3D design actually. 3D design, and we just develop the model. Manufacturing is then taken care of. Dinesh, sir, what are softwares available for simulated additive manufacturing? Dinesh, there are multiple softwares. There's people who are there in manufacturing, like Siemens, they have NX, then EOS, then 3D Systems. They're all providing different softwares to simulate the additive manufacturing. Now, when we develop the model, earlier we just do the analysis based upon the general non-conventional CNC manufacturing or machining. So now we can also have additive analysis. NX is coming with the new version. NX, it is PLM 13 actually. So in that, the new versions and the factory design for additive manufacturing. So all these, there are certain softwares to simulate for rapid manufacturing or for additive manufacturing. Then is Akhil. Can we use titanium as a filament? Akhil, titanium is one of the metals which have very specific properties. It has very high strength to weight ratio. Titanium is used as a powder in manufacturing, not as a filament. Developing a titanium filament would be a great challenge, and people have not come up with this thing till now. So it is used as a powder, and that can be used in any powder manufacturing processes. Shubham, which journals would be most useful related to the benchmarking comparison of various additive manufacturing technologies? Shubham, there is a journal known as additive manufacturing. It was known as rapid manufacturing. Rapid prototyping was a journal which is now called as additive manufacturing, because rapid prototyping was just developing prototypes to test, and those tests were then taken for the feedback, and then the final products were developed using the conventional CNC manufacturing. Now, this rapid prototyping processes are being used for mass production. So journal are also now changed their names from rapid prototyping to additive manufacturing. That is one of the best journals in mechanical engineering because of the potential of this field. Otherwise, the certain other journals, product design and International Journal of Machine Tool Manufacturing, all those are working in this additive manufacturing these days. Yes, please. Any other question? Yes, please. Any other question? Professor Ramkumar is also here. You can ask any question. Professor Ramkumar or I can both reply to you. Sir, in ballistic particle manufacturing, how the exact position of droplets is achieved?
Why should you achieve?
Suraj, one thing is, why should we achieve the exact position of droplets? One thing I would like to request you, please wait for the lecture to come. We'll have lecture in the week 6, 7, and 8 on rapid manufacturing processes. There we have some explanations, and then you can come up with the questions, and we'll tell you the information that is not that is left in the lecture. Akhil, sir, what is the minimum diameter of nozzle? So these are very specific questions. Akhil, there is no minimum diameter, I could say. It all depends upon the application that you do. There's certain accuracy. For instance, if you are manufacturing, and if you are talking about nozzle, I think you are talking about the powder manufacturing. So it all depends upon the kind of accuracy or kind of the size that you need to achieve. Dinesh, sir, making a composite filament is possible for additive manufacturing? Yes, it is possible. Obviously, as we have discussed, when we have pellets or different small granules from which the filament is made, if we mix different granules, and that would make a composite filament, and people are even mixing biodegradable material with them and developing filaments which are a little greener than their counterparts. So that is quite possible. So Dinesh, Akhil, Suraj, Shubham, Prajina, Akshay, Kalpana. So any other questions, please? So in this course, we have covered till reverse engineering and the laboratory demonstration on 3D scanning till now, till 5th week. In 6th, 7th, and 8th week, we'll have processes. Then we'll discuss about rapid manufacturing materials and post-processing concerns. Then certain other things like costing, then factory design for rapid manufacturing, all those things we will cover. So if you don't have any questions, then we can stop here. We'll just wait for a minute or so. So if you have any questions, you're welcome. Otherwise, we can stop here, and you can post any questions anyway in the forum. I didn't understand in which case reverse engineering is illegal.
Illegal, nowhere. If you do reverse and produce the same, it is illegal.
Ayush, reverse engineering, as we have mentioned in the lecture as well, is not for copying the same product. It is just to understand the product, have the feel of the product. If we scan and produce the same product in the market, then that product might have patent and something that is illegal. If we understand the product and scan that and use our all information or our knowledge to develop a similar products or to have some add on to this product, that is not illegal. So this is not illegal. Reverse engineering is a great or a very high potential field. It is also working. Dinesh, is there any specific property is required for filament used in medical field?
The requirement.
it all depends upon the requirement. In medical field, medical is a very broad field. If we talk about medicines, we need to talk about the medicines at Professor Ramkumar said paracetamol, what are the salts in them. And if it is an artificial part, we call it prosthetic parts. Now we're calling it artificial parts. So it all depends upon, there can be cellulose, bio inks, and it all depends what type of application we do have. And in medical field also, we have medical or medicines manufacturing equipment. In those we can have different gears made of nylon and all those things. It is all medical field. This is a very broad question and very broad field is there. So please, any other question? We are already here for 40 minutes. We started at 2:50. Swapnil, can you suggest an institute or professor researching on design, development, and manufacturing of bioimplants, prosthetics using additive manufacturing? Swapnil, I believe this question is again out of the domain of the course. You can definitely search in different institutes and search about the professors. So we cannot suggest any professor here in this specific live session. So Shubham, can you tell us about Indian 3D printer manufacturers? There's certain 3D printer manufacturers in India and abroad, and these days printers are even available in about 20,000, 50,000, 1 lakh, 30,000. There's very low cost printers are available, and
lot of startups are there.
Those who have developed the 3D printers. To name some big pioneers, 3D Systems and Startasis, yeah, Startasis. These are the big companies, those who are supplying the 3D printers to all over the world, and they have their units in India as well, selling units. So otherwise, they are small companies, those who are able to provide the printers with different specifications. Sir, it's Marfin. Sir, can I use 2D photo to get 3D model print model?
Yes.
Yes, you can use that 2D photo. You have to do some image analysis on that. After image analysis, you have to see, you have to compile different images in different views, and that can be used to develop a 3D model. And this is also a very interesting field. I would suggest you to search something on this. You'll find your YouTube videos and also some research papers on this. Imagineering, that is, people sometimes call this as like it. So Marfin has just joined. So any other question, Marfin? Or Shubham, Swapnil, Dinesh? Otherwise, okay, I believe there are no other questions. So we are stopping here, and you are open to ask any questions in the forum. So thank you so much for being in the course and taking this course. So your questions and your presence here always motivate us to put some more into the knowledge and into sharing the knowledge. So thank you very much again, sir.
Yes, so from my side also. So there is one question posted by Dinesh Babu. What are the softwares is available in converting 3D file into STL for FDM additive? See, STL files are nowadays, they are called as neutral files. Almost all the good softwares which is available today, they will always have a file exchange. So that is done by star dot whatever it is. So you can get it done. Shubham, so yeah, thank you very much. Akhil, can we make a 3D model of city? Yes, it is possible. So using LiDAR, people are trying to do. So basically what happens is laser is used there. Laser is used to scan 1D data. Then you start stitching 1D data with a GPS system. So you start building it, and then you can do. Stitching of images from 2D to get 3D is very popular. And when you use the polymer based process like ballistic, somebody was talking about 3D printing. So you can use that for city building. So wherein which you can also have color integrated into it. You can show water, you can show this, that. Everything is possible. Okay. During my intern at IIT Indore, I was trying to make electrode material through FDM for chemical sensing. Okay. Can you please suggest me any cheaper material? Sir,
Okay,
this is a
not
domain
yet.
specific Kalpana. So sorry, please pardon us. Through Google 3D, try it, Akil. You can try it. Dinesh Babu, thank you, sir. Had a great discussion with both of you. Yeah, pleasure is ours. Any more questions? And Kalpana, so you are asking a domain specific, which is beyond this course. And electrochemical sensor is one different area. So sorry, we will not be able to help you.
Okay, then Murli.
Yeah, thank you, sir.
Thank you. So everyone is
Marfin
telling thank you. So
session
thank you
is
so
very
much.
interesting. Yeah. So since many people have thanked, so it is time for us to say bye. And thank you so much. And thanks to Murali, who has been all the time helping us in getting connected and improving the connection, as well as the course presentation feedback from you. So before even we both landed here, he took a printout. So these are the forum questions. So you should also say hi to him and thank him. So Murali here.
Hi everyone. Thank you so much.
Yeah, it's okay. So thank you so much, Murli, for always being very supportive in all the technical and other assistances. So he is a very good friend. So we have a good, very personal and professional relationships. So thank you so much. Thank you, everybody, and thank you, Murli, and thank you, sir.
Yeah. Thank you. Yeah.